Good morning, everybody. I'd like to welcome you and thank you for coming to the first Integrated Medicine Research Lecture Series, or lecture of the year. Today we're very happy to welcome Chris Mooney, who's going to be speaking to us on the subject of do scientists understand the public? An explicit goal of our new strategic plan, which will be out in the next month or so, is about enabling better evidence-based decision-making by the public and by healthcare providers and health policymakers about the use of complementary and integrative medicine interventions. And as you might imagine, we're probably not unique, but we have a particular set in NCAM of interests and issues around engaging with the public in discussion about controversial and complicated scientific topics. So Chris's talk today is particularly welcome and timely. Chris is a science and political journalist now based here in Washington. He's the author of several books, including the one that most immediately got him here, which is up on the screen there, Understanding Unscientific America. Yeah, how scientific illiteracy threatens our future. He's past visiting associate in the Center for Collaborative History at Princeton University and a 2009-10 Knight Science Journalism Fellow at MIT. He has authored many things, is featured regularly by national media, and will be speaking with us today on mainly on a topic that was a result, as I understand it, of an American Academy of Arts and Sciences project on concerns about examining the ways in which scientists engage the public and how their mutual understanding could be improved. So it's a real pleasure. Please join me in welcoming Chris Mooney.
Hi. So one clarification. I did this paper called Do Scientists Understand the Public for the American Academy of Arts and Sciences. I'm going to tell you about that, but I actually decided to fold it into a talk that's on a bit of a broader subject, which is, the gap between science and the U.S. public. So we're gonna hit both, and I'm gonna frame it in that way, if that's okay. It is a privilege to be here. This is my most delayed talk ever. It was first delayed by snowpocalypse, and then it was delayed by something else I had to do, and then delayed by something else I had to do. So I'm glad that 1 year later, we made it happen. 11 months. And the broadest frame I want to sort of cast out there is discussing why it is the United States has a dysfunctional relationship with its scientific community and what might be done to change that. It's a bit of a staggering paradox when you think about it. We have the best universities in the world. We invest more in science than any other country, and here we are at the center of one of the largest parts of that investment. And yet we are allowing ourselves to fall behind other countries in science education. We're falling behind countries like China in green energy innovation. Meanwhile, the U.S. public doesn't even really quite understand what's wrong, what's being missed, why science matters to their lives. How could something like this happen? That's the subject of the talk, but first let me answer a simpler question. What do I know about it? And why am I speaking on it? I'm not a scientist. I'm a journalist. I was brought up in a science-centered family, and I think that kind of shapes everything that I do. My grandfather, Gerald Cole, was an evolutionary biologist at Arizona State University, and he sort of rubbed off on me growing up. He was sort of this irascible, eccentric, elderly scientist character. You've probably met some of these, right? And in this particular case, he was also creative. We had an invisible friend that he spoke to for us, and this invisible friend's name was Chuck. And that was short for Chuck Darwin. So Chuck would be with us, Chuck would be hanging out, and Chuck would be like there at the dinner table having a drink with the family. So that's the kind of upbringing I had, and that's why I care so much about science. But it also sets me apart from my fellow Americans who have not had have not been steeped in the scientific worldview, so to speak. And how different are they from me? How different are they from you? This is the topic that I took up with Cheryl Kirschenbaum in our book, Unscientific America. And we started with an example that may seem a little strange, maybe even trivial, the demotion of Pluto from the solar system. And some people said, you know, who cares? But actually, if you want to find something that Americans, A, know about science, and B, are very motivated surrounding science, the demotion of Pluto is like a big, big thing for them. Because not only do they know it happened, but they were extraordinarily outraged, extraordinarily upset that science had taken away the underdog planet from them. And they responded to this perceived slight from the scientific community in the only way that they really could, and that was by coming up with all kinds of clever T-shirts and bumper stickers with slogans like these. I own some of these: "Dear Earth, you suck. Love Pluto." There's the gap between science and the public right there. Americans aren't stupid, they're very clever, but they don't quite get what these scientists are up to. More seriously, we're in pretty bad shape when it comes to the public and its grasp of science, firstly, and I think we've all heard this. There's pretty poor levels of factual knowledge on the part of the broad public about scientific information. So we have, 200 years after Darwin's birth, we still have 40%. And that's actually gone down a little, not accepting evolution and believing that God created humans sometimes in the last 10,000 years or so. So Americans many of them have missed out on the greatest scientific revolution of the last 200 years. They're not Darwinians, but not only that, they're also not all of them Copernicans. Only 53% know how long it takes for the Earth to orbit the sun. And before we sneer at people who don't understand this, I've tried out on my very well-educated friends a question that's fully implied by the Copernican worldview. Why do the seasons change? I asked them this, and they do not know the answer. They cannot get it, and they always say the same thing. They stop and think, and then they say, isn't it because the Earth is closer to the sun during some parts of its rotation and further from the sun during other parts of its rotation? No, but some of this stuff is hard, so we gotta be careful about how we judge people in terms of just their factual knowledge. If you take a topic, though, a policy-centered scientific topic like climate change, again, you'll find very low levels of literacy about some of the key facts that we think people would need to understand if they were ever going to make up their minds about the topic. A giant gap between what scientists think is happening with the climate and what the public thinks. Americans have this misconception dating back to I don't know how long. They think that it's about the ozone hole. They think that spray cans cause global warming, because I think the hole in the ozone layer was in some ways better publicized and explained to them than climate change ever was. If you give them a test, do they know the basics of climate literacy, you're going to get most people getting C's, D's, or F's. And you would find the same on many, many other subjects of policy importance that are scientific in nature. I don't want to suggest that the problem is merely people's lack of knowledge, the absence of something in their heads. Just as important is the fact that they're not closely engaged with the scientific community. They don't know what it's up to. They don't know why they should care. And again, we've got lots of facts that demonstrate this. Just 18% of Americans know a scientist personally, so that means all the rest are going on some type of stereotype, probably a pop culture stereotype. Maybe they think the TV weatherman is a scientist. That's something that would outrage climate scientists in particular to think about. Just 13% now follow science and tech news very closely. That number has been going down. Meanwhile, attention to science in the news has also been going down in a kind of little feedback cycle there. 44% cannot even name a scientific role model, so you call them up and that's silence on the line. And among those who do actually give a name in response to this question, who do you think that they name?
Dr. Phil.
I haven't heard that one before. Any other thoughts? There you go. One out of three. But these are the top three. So America's scientific role models are either not scientists or they're not alive. The public doesn't know a lot about science or even who scientists are. But if we're going to fix this problem of a gap between the public and science, we need to ask the inverse question too. And here we go. Do scientists understand the public? The short answer is no, not all of them. Some are starting to become attuned to it, but it has not been a priority before. And the reason I know something about this is because I was asked by the American Academy of Arts and Sciences to write a paper based on a series of workshops they'd done, expert workshops, to look into the question, do scientists get the public, and more specifically, do they understand what's motivating people when there are conflicts around scientific topics? And the issues that these workshops looked at were the future of the internet, nuclear waste disposal, personal genetics, and energy change, energy innovation. And generally they concluded that no, often the scientific community doesn't understand the reasons for the resistance that it's experiencing. And more specifically, when we see people rejecting scientific results, as we see all the time, topics like evolution, climate change, and many others, you often get a familiar dynamic in which scientists want to and try to set the record straight about the facts and convey correct, accurate information, but then the same thing always seems to happen. The facts don't really move people or change their minds, and the conflict doesn't get any better and doesn't get solved. And then some of the scientists will say, oh, people are irrational. Sometimes they'll say people are stupid. People are not open to the facts. Actually, what's going on usually is people have non-scientific motivations, and the facts aren't really what are motivating them to begin with, so getting more of them is not really going to change them. And it's important to understand what is actually driving them. So one of the case studies that was looked at here was the long and seemingly unending battle over storage of nuclear waste at the Yucca Mountain repository. And here, if you look at the history of the issue, it's a great case study of this because it's been studied for many, many years to determine whether disposing of waste here would be safe. There's a lot of money and a lot of time has been spent on this question. But the people who resist disposal of waste, mainly Nevadans, all Nevadans at Yucca Mountain, that's not really what they're tuned to. What they care about is the perceived injustice that occurred 20 years ago, more than 20 years ago, when their state was singled out to begin with as the state that would house all of the nation's nuclear waste. This was perceived to be unfair. Why should Nevada be the dumping ground of the entire country? And they called the legislation that set this up the Screw Nevada bill. And so they were dead set against it from then on, and it didn't matter really what you found later about the safety of disposing of waste at Yucca Mountain. It mattered that you'd set up this situation where you had a lot of public resistance. And so this was actually tested. The American Nuclear Energy Council ran an ad campaign trying to use scientific messengers to convince people who were resistant to the repository that, hey, it's okay, it's going to be safe. And they triggered a backfire effect where the scientific arguments meant to make people more open to waste disposal at Yucca Mountain actually made them more resistant to waste disposal at Yucca Mountain. We see this kind of thing actually quite frequently. We often find out that more information about a scientific topic doesn't make people more accepting of what scientists want them to be accepting of. Let me give you another example. Climate change. This is data from Pew, which is really staggering, kind of mind-blowing to many researchers. If you are a Republican, the higher your level of education, the less likely you are to accept that global warming is human-caused. If you're a Democrat or an independent, precisely the opposite is the case. Now, what is going on there, right? We think that we're going to educate people, we're going to make them smarter, we're going to make them better critical thinkers, and then they'll be able to assess scientific information accurately, and everybody will go along with what the expert community says. Clearly doesn't work that way. In fact, I would postulate that what's going on here is that if you start out with a political predilection, higher levels of education make you better at researching and getting information that bolsters your point of view, better at arguing your point of view, and better at persuading other people to accept your point of view. And so education is not necessarily a panacea when you have a political conflict that involves scientific facts. Happens on the left as well. I call this slide Dumb and Dumber. So vaccination is another issue where education seems to make matters worse, or at least it seems to correlate with more resistance if you already are inclined to suspect that vaccines aren't safe. New England Journal of Medicine found that the children who were going unvaccinated by parental choice, not by lack of access, were likely to have come from families that were relatively more advantaged. So they were richer, they had a married mother with a college education, and the parents in these families were more likely to feel empowered and self-educate about vaccines. They would go on the internet, they would find information, and they would find more and more information. And there's tons of information. A lot of it's biased, a lot of it's unreliable. Jenny McCarthy called it, on Oprah, she said, "I've learned from the University of Google." But that's the problem. Nobody's stupid. The issue is not stupidity. The issue is motivated reasoning, rather, which is much more difficult to deal with. So For all these reasons, the public is very much lost when it comes to science, not tuned in, not necessarily aware of what it's missing, and sometimes interpreting information through a political or ideological lens that makes it very hard to change people's minds. And occasionally something like science comes across the radar and everybody perks up, but it's usually something like Pluto. That's what we're trying to fix. But at the same time, we also have a scientific community that, by and large, has not made a lot of effort over the last couple of decades to understand the public or know how to relate to it, although that's changing. But that's also something that needs to be fixed. And I don't really think you can fix one without the other. To quote Carl Zimmer, who's a great science writer and a friend of mine, he said, "It takes two sides to make a divide." And that's true. So there are problems on either side, and I would say that as people who care about science, people who want more appreciation of good information and how to think about it on the part of the public, rather than looking at the gap and saying those people over there need to move closer to me, I think what we should say is, what can we do to move closer to those people? So that was the argument of Unscientific America. And in order to figure out how to move closer to those people, I want to introduce a framework that's actually more than 50 years old now for thinking about what we might do. And that's the framework that was come up with by a guy named C.P. Snow, who was a British novelist and also trained as a physicist. And he wrote many novels, also a lot of nonfiction, but he gave the most famous thing he ever did was a lecture in 1959 entitled The Two Cultures and the Scientific Revolution. And in this lecture, he described British intelligentsia, the intellectual elite, as being polarized because they came from different backgrounds. The scientists on the one hand, as he put it, and the literary intellectuals on the other, between the two, a gulf of mutual incomprehension, sometimes hostility and dislike, but most of all, lack of understanding. And again, nobody was stupid here. Everybody had different backgrounds, and those different backgrounds made them unable to communicate, unable to see eye to eye, even though both camps could have used the insights of the other. I think that very much describes the problem in the United States today as well. I don't think that the gap between scientists and the literati is our biggest problem. Actually, I think that the intellectuals are all walled off from everybody else, and they have more in common. I think it's different from Britain in that way, different from mid-century Britain in that way. But I do think that this framework of thinking about problems as being two cultures problems is a very helpful one, and it will help us figure out how to get scientific information to people who aren't getting it. So what are the two cultures gaps in American society that really ought to trouble us? I would say that they are the gap between science and politics, the gap between science and journalism, the gap between science and entertainment or the creators of culture, and the gap between science and religion. So I want to then go through those in some detail and talk about why it is that we have in all of these cases two groups of smart people who don't see the world the same way. We'll start with politics. I'd written about this a lot prior to the 2008 election, but the 2008 election really made me appreciate even more how it is that scientists see the world so differently than politicians. During this election, I and friends and colleagues came up with an initiative that maybe some of you heard of called Science Debate 2008. And what this was just a simple plea that, hey, it's an important historic election, and whoever's president is going to make all kinds of policy decisions that are science-based and affect everybody. So why on earth are they getting asked more questions on the campaign trail about UFOs than climate or whatever? So we thought that they should talk on the campaign trail about scientific issues, and moreover, that there should be a presidential debate about scientific issues. So we drafted this short statement. And it resonated in a dramatic way among the scientific community. So before long, we had over 100 university presidents endorsing the statement, many scientific societies joining the initiative and backing this simple idea that there should be a debate. And we felt pretty good about ourselves. We also had 30,000 individuals sign up and all the rest. We were going through these long lists of people constantly looking at who had signed up, and it seemed to be a broad array of scientific leaders in the United States. So we felt very good about ourselves. Wow, you know, we've done something. We've rallied science behind this simple proposition of a debate. But then we also had a responsibility, which was, I guess we better contact the candidates now and talk about this idea. And that's when the incredible two cultures gap showed itself, because the scientists who were coming to us endorsing this proposition were thinking, what a great idea. We'll have a public debate about science and technology. It'll be nationally broadcast. Everyone will see it. We will enlighten the electorate. We will show people why science matters so much to decision-making and why it affects them. And we'll have a better election, we'll have a better policy making as a result. Okay, politicians or their campaign consultants, which is really who we ended up talking to, this is more like what they thought. They thought, what a nightmare. I'm going to put my candidate on national television. He or she, Hillary was still in it then, he or she is going to get some question about different kinds of quarks. Totally bomb. It's going to be this Dan Quayle moment. We're going to lose a week trying to explain it away. We're going to go down in the polls, spend a week not talking about what we want to talk about. And, excuse me, what constituency are we doing this for again? Who are you? And don't you already vote for us anyway, or don't you never vote for us? Tell me how this is supposed to benefit my candidate. And that was something that I don't think we adequately answered. I mean, if this kind of thing is ever going to succeed, that's what has to happen, giving that answer in a convincing way to politicians. Now, it's not to say that all politicians don't get science. There are certainly some very science-focused ones. This is Rush Holt, who represents Princeton, New Jersey in Congress. He is a physicist. He's won Jeopardy lots of times. Okay, this guy gets science. And if you drive around Princeton, as I did, and you look at the car in front of you, you will see bumper stickers saying, "My congressman's a rocket scientist." That's the exception. That's not the rule. Another exception is Vern Ehlers from Michigan, who's a Republican, Holt's a Democrat, and he tells the story of having to rush to the floor to prevent his colleagues from killing off an appropriation for game theory research because they thought that it involved sports. So this is a problem. We have this gap. And the general verdict, I think, on Congress in particular is here's people, again, not stupid, but overwhelmed by information coming from all sorts of sources of varying degrees of credibility. Lobbyists, think tanks, blogs, their constituents, other members of Congress, and they don't necessarily know how to handle it. They don't know that they should be handling it in a particular way. They don't have a scientific advisory office anymore. They don't see science as central to how to do their jobs. And that's the kind of thing that we have to fix. But you won't fix that kind of two cultures gap unless you make science useful and show people on the other side why they need it and why it can help them at what they're doing anyway. So the gap between science and politics is a huge one. We also have a gap between science and the media, and it's also a problem area. And for a long time, scientists have complained about how journalists cover scientific topics. They complain about, for example, this idea of 50-50 balance no matter what the issue is. We'll just quote one scientist on one side, quote one scientist on the other, and split the difference. That doesn't work on topics where there's a strong consensus and a few contrarian dissenters. But I'm here to say that whatever those problems were with old patterns of media coverage of science, they are bound to get worse. In fact, they are only getting worse because of the complete destruction of a large number of careers in science journalism due to the collapse of the prior business model of the newspaper industry and other parts of the media being killed off essentially by the internet. So look at the coverage of science now. Pew found that if you watch 5 hours of cable news, you can expect to see 1 minute devoted to science and technology. This is funny because I was on cable news. I was on Morning Joe on MSNBC, and they were talking about my book. So this is actually on the dust jacket, I believe, this particular little fact. And so it was read on the air, and then the host, Micah Brzezinski, said, "Wait a minute, that's us he's talking about." And I got 3 minutes on this occasion. So I kind of kicked back against the trend a little bit. The Shorenstein Center at Harvard, for people in the press, found that over the last couple decades, we've seen a 2/3 decline in the number of newspaper science sections, especially devoted to this topic. There's some famous moments for the decline of science journalism, like when CNN cut the science and tech unit in 2008. The Boston Globe actually cut back, in the center of the biotech industry, its own science section. And this has been a recurrent trend across the country. Andrew Revkin of the New York Times is sort of a poster child of it because sort of a leading journalist covering energy and climate who decided, he was not cut, he decided that, hey, this is a smaller and smaller slice of what people are talking about and how to talk about science. And so he wanted to do more teaching and kept his blog, but stopped being a reporter for the Times. I want to tell you another story about this kind of decline of science journalism because I think it's a very telling one. We wrote about this in an article in The Nation. The story of Sabin Russell, who was the San Francisco Chronicle's one of their science reporters who specialized in the coverage of global health. So this is the kind of journalist who had been to Africa to cover the AIDS epidemic, who had covered bird flu. Well, in May of 2009, I think everybody here probably remembers that we had the gigantic focus on H1N1. At exactly this time, Sabin Russell would have been the perfect person you would think that the Chronicle would put on this story, but at exactly that time, Sabin Russell was cut. He faced a pressured buyout situation. Why is that? Because the trend has nothing to do with the importance of science to the news, to the public. It has everything to do with the media industry changing and the fact that they just cannot subsidize these kinds of jobs, because these are not the parts of the paper that make money. In fact, these were never the parts of the paper that made money. It's just that they were so flush in the past that they could actually have good information along with entertainment and advertising. Well, that's not the case anymore. So it's completely a matter of economics, and whatever problem existed between journalists and scientists before, expect it to get worse. So the question then becomes, well, can the internet save us? And I'm afraid to say, there's a 10-year-plus blogger, I'm still kind of skeptical, cynical about that. It's certainly true that now Americans go to the web for science, and that's not going to come as a shock to you. The web is now second only to television as the #1 source of scientific information for people. And of course, when they're looking for a particular scientific topic, like a medical topic, like, what is this thing that's ailing me? They're going to Google. They're not going to go to an encyclopedia. They're not going to go to a book. They're not going to go to a magazine. The question is this a good thing? Does science content on the web somehow beat back against the trend of declining science content in the old media? And here I'll say it's mixed, basically. There are some good things. For example, science bloggers can tar and feather stupid things in the old media, like George Will's claims about global warming would be a great example of that. He actually claimed that according to a leading source on global warming, there's been no global warming in a column in 2009, and this was such a big deal because he was abusing a scientific source so badly that bloggers about science and bloggers about the environment got extraordinarily outraged and made such a stink that the Washington Post did eventually have to really pay attention to the fact that George Will had said this. And so the ombudsman did a story about it, and the head of the World Meteorological Organization got to publish a letter saying he's wrong, these are our statistics, the 2000s are way hotter than the 90s, etc. And I wrote an op-ed too. So the blogs can hold the old media's feet to the fire and correct the record to some extent. That's important. But there's a lot of problems with the online conversation about science as well. I think they're all captured nicely in this cartoon, so just give it a read for a second. It's obsessive, it's navel-gazing, it's always negative, and good information and bad information are just sort of fighting in a yin and yang situation online. Neither one wins. They operate in different islands, and their audiences are completely different. So you'll have the people who attack vaccines, and then the people who attack vaccines, and nobody changes their mind. It's just everybody sorts themselves into the communities where they already believe. The 2008 Science Blog Award, the Best Science Blog Award, was won by a blog that denies the science of climate change, because it was the most popular, and that's what counts. And you have this effect that people like Cass Sunstein have written about, where if people sort themselves into groups that are homogenous, where everyone agrees with them in terms of what information they're consuming, then there's a tendency to grow more extreme in your convictions and more sure that you're right and the other guys are wrong. And that's what the old media, when you were reaching a broad audience with a shared body of information, I think was able to more mitigate against. So there's good and bad, but I don't think it's any replacement for what's been lost in the old media. What about, this is how I started worrying and learned to doubt the blog. What about the entertainment media? Freaks, geeks, and villains. That's who scientists are. And let me just run through some of my all-time favorites for the treatment of science in Hollywood and talk about then some of the stereotypes that we see. People see The Day After Tomorrow? Anybody? So what happens in this one? Global warming triggers a new ice age. Doesn't make a lot of sense. The world's attacked by massive freezing upside-down hurricanes that travel over land. So hurricanes, I don't know if people know, but they get their energy from the warm sea surface, and they cycle it up and essentially expel it high up in the atmosphere. Well, these storms in this movie, they take the freezing air from the stratosphere and they fire it down at the ground and turn people into statues of ice. But the characters survive by burning books in the New York Public Library. That's how they get through the cold. Here's another one, The Core. This was rated the worst sci-fi movie ever, I think. The worst scientific sci-fi movie. Anyone seen this one? Yes. There's always a few in my crowds, I find. So the planet's core stops rotating, and this unleashes an assault of deadly microwaves from space, like the microwaves in your oven. But the microwaves in your oven could not destroy the Golden Gate Bridge, as happens in the film. And moreover, I'm told by physicists that if the Earth's core were to stop rotating, microwaves would be the least of our problems. So what are they going to do? They got to go to the center of the Earth, and they got to restart the core's rotation, and of course they got to use nukes. How are you going to get there? It's very hot. Well, they come up with a material called unobtainium, which is actually the material that they're mining for in Avatar, strangely enough, afterwards. Here's one that the science crowd will get, and particularly the biological science crowd will get. Red Planet, this is the worst of them all, probably. Anyone seen this one? Okay. They've got a geneticist in this movie. Tom Sizemore is the geneticist, and he has to give a speech identifying himself as the nerd. So he says, I'm a geneticist. He's introducing himself, and this is going to be important to the plot. I'm a geneticist. I study A, G, T, and P. And I played this back several times. I promise you that he says A, G, T, and P. So they couldn't hire a grad student on the set, I guess, and they hadn't seen Gattaca. Okay, so entertainment media is a bit of a problem in terms of its treatment of science as well. We could talk about that more. The biggest divide, I believe, is the divide between science and religion, and this is not so funny, although Richard Dawkins was on South Park. But it tears people apart. It makes people very angry. It makes people fight. And I've been faulted for what I say about this. I've been in a kind of argument with Dawkins and his followers because I say that, hey, I'm not religious. I know you guys aren't either, but we don't need to polarize the public around the question of whether they can have science and religion go together. And let's just look at this, forget about whether you think God exists or doesn't, let's look at this sociologically. It turns out that there's a big two cultures divide between scientists and the religious community. 52% of top scientists don't have a religious affiliation. That's much less religious than the public, even though the public is actually becoming less religious right now. And if you look at self-description, 14% of the public self-describes as evangelical or fundamentalist. I think if you put labels on people, you might want to blow that category up much higher. But in any case, that's way, way more than scientists who would describe themselves this way. So we have very different worldviews. And then we have a public dialogue in which the middle is sort of torn between extremes. We have the new atheist movement that is using science to blast religion. We have movements like intelligent design that are religiously motivated and using that motivation to attack science. We have the public that I don't think wants to be in either camp and doesn't want to think that the two are opposed, but we have the media that likes the conflict and treats it that way. People, I think, would like to have science and religion go along and have some way of thinking that they can be completely accurate in what they know about the world and also have a belief system. One way of bridging this divide, I think, emerges, it's already sort of happening, emerges from the research of Elaine Eklund at Rice University. She's a sociologist, and that is to focus on spirituality rather than religion, because it turns out that many scientists who don't believe in any particular way nevertheless describe themselves as spiritual, and this was surprising, but nevertheless it's in her data. She looked at the religious views of scientists, and she sampled top scientists at top universities, and what she found was that half say they're spiritual. 20% are spiritual but not religious. This is an increasingly trendy category in the United States generally, but when scientists say this, it doesn't mean, I'm kind of into Buddhism, I'm kind of into Catholicism, and I like crystals. It means something more like, I get this sense of awe when I'm out in the natural world studying living things. That's what they mean, and they don't have any particular theology attached to it whatsoever. One of them even told Eklund, I'm not some flipping New Ager. But nevertheless, this is showing an interesting way that science and religion can possibly get along a little bit better in the future. In fact, Richard Dawkins himself on Al Jazeera said that spirituality can mean something I'm very sympathetic to, which is a sort of sense of wonder at the beauty of the universe, complexity of life, all of these things that Einstein said that he felt a sense of wonder about. But, Dawkins quickly added, I don't want to confuse with the supernatural, which means victory, right? We've actually solved the conflict over science and religion. It's over, it's done with, and we don't have to worry about it any longer. The big issue raised by all of this is how are we going to bridge these separate gaps and bring scientists and the public, and especially these important sectors of the public, closer together. And I argue, and some people don't like this, but actually I think it's catching on a bit, I argue that the onus surprisingly falls on scientists to do this. Since, after all, they're starting out from this great position of advantage. They know what people are missing. And people don't know what they're missing it. But the scientists know. They haven't historically made it a priority. After Sputnik, scientists' priority, they were heroes in America, and their job was to research and sometimes teach. But some of them didn't even do that very much. But their job was not to become communicators and to engage in public outreach. That's changing now. There's an increasing focus on this, and I want to prod things in that direction. And you can explain that it is in the interest of scientists themselves to go in this direction because they will understand the public better, and they will maybe find some movement on these issues that have frustrated them for so long. They will also, perhaps, if they're better communicators, actually get some protection, which some of them need. If you're familiar with the ClimateGate scandal, one reason that climate researchers in particular are embracing new communication initiatives today is because they feel that they got burned, and they did, in a terrible way in November of 2009 when these emails were stolen. And I think everybody heard about this from the University of East Anglia in England, and then they were taken out of context in order to suggest that, hey, these climate researchers are committing actual research fraud. The emails didn't support that, but if you took a couple lines from them, you could make it appear that way. So afterwards, some scientists tried to communicate, set the record straight, etc. Michael Mann was one of them, and he said he wasn't getting any help. And so increasingly, there's a lot of thinking, what did we do wrong? What can we do better so that something like this doesn't happen again? And that's just one community of researchers that are grappling with a kind of communication problem and a damage control problem, but there's many others who are thinking about this. If we need a scientific community that does more outreach, does more communication, how do we get it? And here I would suggest that the problem and the answer both lie in the scientific pipeline. This is, I think we know, the assembly line by which you take a kindergartner and you turn them into a PhD. And you lose a lot of them along the way, but nevertheless, we produce quite a lot of them in the end. The pipeline is usually discussed in the context of pretty serious and I think valid concerns about U.S. competitiveness. Are we creating enough scientists? Will we stay ahead of the countries like India and China that are coming up fast in the rearview mirror, creating more and more scientists, creating more and more innovation? There are reasons to think that this argument is valid in the sense that our scientists are increasing. This is NSF data. We're creating more and we lead the world, but also that little red curve is China, and they're coming up fast. So if you're concerned about the total number of U.S. scientists, then yes, we will not always lead the world, and maybe, today's the day that we don't anymore. But what's rarely discussed is that we don't have enough jobs for the scientists we have right now. So if we're going to create more, we better figure out things for them to do. In fact, we better figure out things for the ones that we already have to do. And everywhere I go talking about this subject, I get young researchers, postdocs, et cetera, coming up to me and saying, how can I get a career in communication? Because I'm not going to be my professor. I am not going to follow that track. I know how bad the odds are, and it's not something I necessarily want to do anyway. At the same time, they want jobs. They want that kind of opportunity. Some of them, not all of them. Meanwhile, I think there's an overwhelming demand for scientists who can bridge the gaps that I've talked about. So it seems to me that the answer is obvious. You open up a new career pathway for young scientists who excel in science communication and outreach, and I have an official job description. It will be deadly ninjas of science communication. That's what we need. So in closing, if we do all of this and somehow we find ways of funding all these deadly ninjas and paying for their new careers, what will the world look like? Well, I hope it will look like this. These are the words of my friend Matthew Chapman, who's the great-great-grandson of Charles Darwin. He created the Science Debate Initiative. He is a screenwriter. He put it like this: instead of being derided as geeks or nerds, scientists should be seen as courageous realists and the last heroic explorers of the unknown. They should get more money, more publicity, better clothes, more sex, and free rehab when the fame goes to their heads. Thank you. And now I guess we'll take some questions. Yes.
I was wondering, I don't know if this is on, but in Europe, let's say, how do these gaps compare to the ones you described here, and why is there a difference if there is one?
I mean, it's going to be culture and history. And I don't know every country as well as I know the United States, obviously, but it is really interesting if you think about the UK, which is one I know at least somewhat well, because there you find science rifts, but they're different ones, and they emerge for different reasons. So we somehow accepted GMOs. In Europe, there's much more resistance, and scholars have shown that it's not surprising, that it's rooted in the mad cow problems that they had, so people are very worried about food. And so you see there, you'll see scientists saying these things are safe, they're not going to hurt you, and the European, including British public, not accepting that. But it's going to be country by country basis, and it's going to be historical, and it's going to be cultural in nature. So on the other hand, much more acceptance of climate change there. So what's going on there? You got to go country by country.
Hi, I'm Esther Sternberg. I congratulate you on this fantastic analysis of the problems in communication of science to the public. And I also congratulate Josie Briggs for bringing it up, because this particular area is so fraught with the difficulties that you describe. I myself have struggled having one foot in both worlds for the last 10 or 15 years. And I've seen, the good news is that I've seen a tremendous improvement in the way scientists and the scientific community have embraced the need to reach out to the public. And the very fact that this lecture is taking place on hallowed NIH grounds is really a testament to that. So that's number one. When I tried to do, when we did an exhibition on at the National Library of Medicine, really backed by Don Lindbergh back in 1997, on emotions and disease, the topic of this, of NCAM, mind-body medicine, there was tremendous pushback from a number of NIH institutes to prevent that happening here on the NIH campus. That was 1997. By 2001, when we did another international conference on the NIH campus on neural immune interactions, there was a tremendous rush by all the institutes to get out there and say, we're backing this. So in that short period, there was a turnaround in acceptance of this field, but also in the recognition that we've got to do what you're saying we've got to do, that is go out and speak to the public. There are still pockets of resistance. There's still a culture within science that scientists should not be speaking to the public, that it's simplifying the message too much, it's making the message wrong. There's a culture that we shouldn't be, the whole style of writing is completely different. You know, you have to strip it of emotions. As you said, the media wants the emotions in there. So there's a clash of cultures that I think limits moving forward in this. And then there's also increasing restrictions within this institution preventing us scientists from actually doing this, really for conflict of interest reasons. I am not allowed to mention the title of my books or of my television show here, and I will not. But the rules that were put in place to protect us on in one area are preventing exactly what you are talking about, and preventing us who know the information from getting it out there in an interesting and accessible manner.
Let me, yeah, there's a lot of slices of important things here. Thank you for your comment. You know, it raised several things for me. I mean, first is the Carl Sagan effect, which I think we can talk about. But actually, I wanted to say first that there is an opening of minds about this, and I think it's happening for pragmatic reasons, really. And people keep seeing that, you know, keep hitting a wall. Right? Why are we hitting a wall? Let's understand what the wall is made of. And so what that means is, among other things, that hard scientists, as they've been called, are going to need social scientists in order to understand the public better. And so we're going to see more interdisciplinary collaborations, and we're going to be more open to them. And that's going to be one of the key things that helps. But then there's going to be people who remain entrenched. We saw the story of Sagan, I tell in the book, is that obviously he was the greatest communicator in a generation. I mean, he reached many, many millions of people through television. I think Cosmos reached 500 million people around the world, and it was the most successful PBS thing ever. But then, you know, they put him up to be a member of the National Academies, and there was a split. There was a fight. It's not like nobody supported this. A lot of people supported it very strongly, but a lot of people didn't, and he couldn't. It was sort of a 50-50 thing, and that wasn't enough. I don't think that would happen today. You know, I think there would be resistance. I think there would be less resistance. I think that things are changing, and what we need is to institutionalize a reward structure such that there's recognition for being good at getting science communicated. It requires a different set of skills. It's something that a scientist can be good at, but also a very science-literate non-scientist communicator can be good at. And they need to be evaluated on that basis. And it turns out there's all kinds of empirical measures that you can use to evaluate effective communication, like how many people did you reach, and you could even study whether there was an effect if you actually, you know, sometimes doing a survey is expensive, et cetera. But that's the way it's going, and that's the way I'm glad to see it going.
So I agree with that. I agree it's changing, and I agree 100% with putting in a reward structure. And I certainly agree that it's not just that those of us who can communicate science are being ignored. That would be great if the scientific community just ignored us. But there is resistance and a fight against it. And it's much less than before, you're right, but we need to do something proactive to encourage it. Thank you very much.
Thanks.
Sort of to continue on the point of, you know, who can communicate science. You know, it's great if, you know, we suddenly get a group of scientific ninjas, that, you know, an elite team of 30 people, but, you know, where do those 30 people come from? And when you talk about, you know, we can speak about this institution or others, you know, if I want to talk about my expertise on anything, I need to go through a clearance office. Theoretically, you know, I'd have to get approval from the direct office, the top offices of NIH to start a blog. And, you know, this is just one institute. And, you know, where do you get, you know, maybe I'm good at it, maybe I'm not. But, you know, how does someone become a communicator if, you know, all these institutions are essentially putting up, I mean, there's legitimate reasons for these roles, but at the same point, they're roadblocks to see, you know, who can communicate, who can't. You can't measure how well someone can communicate unless they start trying. And there's universities, this is a bit less of an issue. Scientists at companies, definitely an issue. But, you know, before talking about, like, you know, maybe we just have to throw thousands of dollars at an elite squad of communicators, there's tons of scientists out there, and there's not really much talking about how to facilitate them either, you know, with their job as a paid part or even as a volunteer part to use those to try and communicate.
Well, this is a very important point, and it's one that, frankly, doesn't come up at all in my talks, because I guess here I am at NIH, and that's why it's coming up. And I don't have a full answer to it, because while I know something about the battles over, you know, whether scientists can speak or not when they work for government agencies, which were particularly acute in the last administration, but I understand obviously have not exactly gone away. In this one, I don't have the policy solution that I'm ready to describe right now for fixing it, although I think it is definitely something that people like the Union of Concerned Scientists and others are working on. But I think that you should be, there are definitely reasons why you might have to go through some kind of channels, but in general, we should be erring on the side of being communicative. And if that's not the case, then certainly it's my opinion that it should change. There will be restraints, and there will be people also who don't want to do it, and there'll be people who aren't very good at it. But I do think that we change the overwhelming set of priorities and incentives, and slowly you'll see things happen. And I feel like, I interact with a lot of scientific organizations and societies now, and they're all ramping up communications. So I guess it's going to be a bit more of a struggle than I've probably given paid homage to. But I do think we're going in the right direction, and that's without necessarily speaking directly to how we should change agency communication policies right now.
Chris, I really enjoyed your comments. I wanted to ask you to muse on a second issue. When you think about the Yucca Mountain story, it's very interesting, and of course we've all been following the ClimateGate problems. Can you give advice to the scientific community about the prevention side of these problems? Are there ways in which we could have seen this coming, and by better communication avoided the eventual polarization? Be interested in your thoughts on that.
That's what's really surprising about these, is that if you go back, and these are just two examples, there's so many examples like this. If you go back and look at it, it seems pretty obvious that this was going to be a problem. If you have, with the Yucca Mountain situation, you have a set of people that feel like they're at the receiving end of an unfair decision. This happens with siting of all kinds of nuclear waste disposal, other kinds of, even with siting of wind power facilities, whatever it is. If they don't want it, you force it on them, then you're going to reap a lot of problems down the road. I mean, that should be obvious. So there's all this deliberation now about how do you come up with a better process, because you've got to cite something in somebody's community, and actually you can set things up so that you find a community that opts for it because they see a positive trade-off in some way, so then you won't have that. And different issues are different. What we said, and I didn't go into this, what was said in the American Academy of Arts and Sciences paper about this is that the study actually broke down, interestingly, among past issues that were already polarized, and couldn't we have prevented those, and future issues where we anticipate that they might be, so shouldn't we be working on them now? And the past issues were nuclear waste, clearly polarized, and climate change, country completely divided. How are we going to fix that? It'd be better not to be divided to begin with. But there were things like personal genetics. There were things like synthetic biology, and nano, which is interesting because, well, let me address nano in a second, where you can see that there's an incipient political tension, right? And you can picture how this one might end up being a problem. So what are we doing right now to prevent that? On nanotech, we talked about the National Nanotechnology Initiative and how it had anticipating social resistance, which doesn't seem to have much materialized, interestingly enough, but anticipating it, a lot of the government funding of nano research was focused on having social scientists work on resistance and collaborate with hard scientists, and that's what a lot of the institutes that are funded by the initiative are doing right now. So that's the one sort of success story. I'm not saying that the research saved and prevented the resistance, because I'm not sure why the resistance didn't emerge, but it doesn't seem to have. But that's the kind of thing that you want to be applying to all potentially contentious issues, and I think you can see them coming. I think you can see synthetic bio coming. I think you can see, for a climate-related one, you can see geoengineering coming. And you can take steps now to not let it get as bad. Yeah.
I enjoyed your talk. Thank you very much for it. I have heard for many years people talk about the need for scientists to get out and speak to the community. And one problem I have there is, who is the community and to what end? Is it to generally educate the public about science overall? And you've been talking a lot about very specific policy issues. And with policy, science often ends up being about the 10th thing that determines what the policy will be at the end of the day. So I wonder if you could talk a little more about scientists going out and talking to the public, what you envision that really to be, and then also the role of education too. There's studies that have shown that kids are very excited about science until about 4th grade, and that's also about the time when teachers lose the ability to understand the science that comes after that.
Oh, well, so there's a lot there, and I think it's two different things. But it's hard to be precise about the first part of the question, to whom, because we're going to have a lot of different scientists with a lot of different areas of expertise interacting with a lot of different communities or media outlets, channels, etc. So what I would say is that it's going to be specific to the individual scientist, but all of them ought to be strategic about precisely the question that you're asking, which is, who is my audience? What is the channel by which I'm going to receive them? Am I going to give a public talk? Am I going to create a blog? Am I about to do a media interview? What is this? And how many of them will I reach that way? Is that the channel that they're even paying attention to, or am I not supposed to be using this one at all? What is my message when I'm and this is starting to get into all of the communication training techniques that I actually do working with NSF. We're doing these kinds of trainings. So because there's so many different communication opportunities, all I can say is it's something that needs to be planned in advance and needs to be thought about in advance, and it needs to be done strategically to achieve a particular goal, and then you need to assess whether the goal was matched. Education. So the United States has a big science education problem, and I didn't directly touch upon it, although I certainly acknowledge it, and it is what you describe. And kids do get turned off of science at some particular age. And it's interesting, there's a study we talk about in the book where it turns out that if you ask, forget what age kids they are, but if you have a scientist go and speak to their classroom, and it's a young scientist who is female or not white, they don't think it's a scientist. They don't believe that that could be a scientist, because their stereotype is more powerful to them than what they're seeing before their own eyes. And their stereotype is mean, male, gray-haired, and mad. And this is what the researchers said. So, I mean, we've got all these ways in which people get alienated from the scientific community. And we have all these problems with the educational system. I think we should fix them. I think it's a money problem, and it has to be solved on a generational time frame. But I wanted to emphasize in the talk that fixing the educational problem won't fix the contentious battles that are politicized, because it turns out that those don't turn on education. In fact, as I said, with some of them, it appears that education could be part of the problem, or at least smarter people who don't agree with you will be even harder to convince to agree with you. So those we have to deal with a different way. So we have to look at it all. Let me see. Are we getting close, or 2 more minutes? Yeah.
I just want to make one brief suggestion, and that is, I mentioned the National Library of Medicine here. The National Library of Medicine has an exhibition program that is Smithsonian style, that is targeted at K through 12 and college and lay public and decision makers, and they do fantastic exhibitions addressing all these aspects of the questions that you've asked.
Maybe one more, and then, okay.
Hi, I had just 2 quick questions. I didn't know, I heard something last year about NIH partnering with Wikipedia to try and make that a little bit more scientific, hopefully. And the other is about animal testing. It seems almost that I was one of those kids that always wanted to be a scientist, but only one of my professors in college decided to take one class session and educate us about animal testing. And it almost seems like when we're scientists, we're supposed to tell people, that kind of doesn't exist, or we're told to worry about our own security because of PETA. And that's definitely the situation here. It's almost like we're trying to keep the public in the dark. It doesn't seem to be helping. Didn't know if you had any comments.
Well, I don't know about Wikipedia. On animal testing, I haven't written about the topic, and I know that it's a very fraught topic. I haven't gotten my head around it enough to say, like, this is the communications answer to depolarize it. I don't know even if any easy answer to that exists, but I don't know it. But I do think that it's a classic case of why you would need actually research on how people feel and how we could, actually tell them something more about what we're doing in a way that wouldn't enrage them, wouldn't lead to backlash, threats, etc. I think that, and in fact, I'll go further, and I'll bet you there is actually good research on that, and I don't know what it says, but I bet you it's out there. So, yeah.
So let's give a big hand to Chris. Thank you. I'm sure he'll be happy to answer questions. Before we break, though, I'd like us all to just rise for a moment in honor of President Obama's call for a national moment of silence today as a time for us to come together as a nation in prayer and reflection, keeping the victims and the families of the Arizona shootings in our hearts. Thank you. If people have other questions, please come down. Yeah.